Hello everyone, this is Experiment 4, Magnetic Braking with Faraday for Physics 2 by Kiana. So 1. The purpose of the experiment. The purpose of the experiment was to collect observational data of a magnet falling through a conductive tube of aluminum foil, to then model the the interaction between the magnet and the tube computationally, and then to compare the computational predictions with the observed data. 2. The fundamental principles of this lab was Faraday's law, Ohm's law, Lenz's law, and the Biot-Savart law. Faraday's law is stated at the top, Ohm's law with the voltage and the current times the resistance, Lenz's law, and then Biot-Savart's law just as used in the previous experiment. So the results of the experiment. First the procedure was to find the end of the magnet, then label it, of course, and then drop the magnet through a tube wrapped in aluminum foil. And this can be done with a regular tissue paper roll or whatever someone may have. And you're going to drop the magnet through the tube and record how long it takes the magnet to reach the other end of the tube. And then do repeat this 3 to 5 times to obtain an average. So the observations from the experiment, or the data that was collected, is the magnetic moment, the magnetic mass, the length of the tube, the width of the foil, the radius of the tube, and then the average time that it took the magnet to fall through the tube, which was 1.20. This is seconds, so 1 second, 20 milliseconds. And then the other values were here. Now the discussion. What if the resistivity of the conductor were reduced as close as possible to 0? How would the dynamics of the magnet change? Because of Ohm's law, as stated in the fundamental principles, the induced current in the tube would be larger. This would cause the magnetic force to increase and make the magnet fall slower. Another discussion question. What if holes or slots were cut into the tube? How would this affect the ring currents in your model? Resistance in the tube would increase, causing the magnet to fall faster. Now I'll be going over the computational model that was required for this lab. In the first picture, in the top left, you can see all the values that were initiated, which are the physical constants. In the second, in step 1, you can see the properties of the magnet and more additional information. In the third picture is the simulation loop. And all this information is done to calculate the gravitational, magnetic, and net forces on the magnet, update the magnet's position and velocity, and calculate the amount of time the magnet is in the tube and prints the total time. In the second experiment is again calculating the magnetic force and the magnetic force on the magnet and all the things I mentioned before. And here is the output. And the computational model says it was 2 seconds, and I determined it was 1 second, so they were off by a second. But the computational model has been shown to yield these results. Thank you for your time.